Okay. So when it comes to this, like I was saying previously, what we were doing, we are just basing on constant things like constant acceleration, incline positive with a positive gradient, constant velocity on a displacement time graph. But actually, in real life, nothing is constant. Things change almost every time. Time changes, a lot of things changes. So if you are to model things using constant things, then it means that we are not going to get anywhere in life because
Mm,
that thing doesn't even relate to real life. In real life, things
mm,
change. So that's where the need of calculus comes into play. So there's variable acceleration. We're just going to talk about the kinematics, that is the distance, displacements, and other things. But we're going to use calculus. Since calculus really has got a lot of things to do with rate of change. You know, calculus has got a lot of things to do with rate of change, right?
yeah.
Yeah, rate of change. So there's a very simple differentiation question. This is from pure maths, or let me say, is it add maths? Yes, I think add maths. So you
Mm,
differentiate this function. You should know how to differentiate this function. When you
mm.
differentiate this function, what are you going to get?
Um, you get 10x raised to the power 4.
Are you sure?
Wait, sorry. Oh, 15x raised to the power 4
Okay. So 15x raised to the power 4.
minus 24 raised to the power 2.
X raised to the power 2. Say it all, please.
Yeah. Sorry. Then minus 24 x raised to the power 1 or
Yes, X.
24x. Yes. Then plus x raised to the power minus 1 over 2 all divided by 2.
Well, you be taught this one in calculus. That is pure math. How to go straight away to this. But that's what we're going to get
Um.
at during the differentiation. Even though we're
Okay.
going to use differentiation and integration, we're not really going to go in depth into this as it's just let me say a content we are borrowing from pure maths. So since this is mechanics, we're not really going to go into details. But with your pure maths, you go into details when it comes to differentiation and integration. Basically, the difficulty level of the differentiation you're going to see will be function of this nature. In most cases, I don't think you're going to get anything like radical functions, sets, and other things over there. So in most cases, you just get polynomial functions to differentiate, which this is a basic function and it's very easy to differentiate. Okay. Now, when it comes to this part of kinematics, we need to note down three things. There are more, I'll add more to it when we go. So constant speed. From the graph works, you know what constant speed is, right?
Yes.
Constant speed. When even though from the graph, from the definition of acceleration, change in speed is equal to acceleration. So
Hmm.
if the speed is constant, it means that there was no change in the speed. If there is no change in the speed, no acceleration. Are you getting me?
Yes.
Okay, so constant speed implies zero acceleration. Maximum speed also implies zero acceleration. Can you explain this term, the maximum speed?
Um. It's like the highest um like speed an object can move.
Okay, so
Yes.
what has that got to do with the acceleration being
Because
zero?
at that point you can't go higher, so you just be at that point. So it's kind of like constant speed.
Yeah, kind of like constant speed.
Yeah.
That's what I want to hear. Maximum speed
Yeah.
is constant speed. What of minimum speed? You will talk about that
Okay.
one. Okay. At rest, when a particle is at rest, that one too. This is very
Yeah.
clear. The velocity is zero.
Zero.
Okay. In the course of instruction, I'll talk about minimum speed, maximum speed, those kind of things. All this implies that acceleration is zero. But I'll explain to you when the need arise.
Mm.
Okay. Now, when it comes to let me get a fresh page. Yes. When it comes to kinematics as well, you see, when you're talking about rate of change, we associate rate of change to differentiation. And when we associate area to integration, from your art mathematics, if you have to find area under the curve, we're going to do some integration. And if you want to find rate of change, we use differentiation. Let's go to the displacement time graph. What is this line? A line of this nature?
Which one?
This line. A displacement
It's a displacement time graph. So that means constant velocity.
constant velocity.
Yeah.
How will you find the constant velocity?
Um, Using the formula, right? So
Well, if
the
there's no
different
formula,
gradient of the line, yeah, gradient
gradient
on the line.
is the gradient of the line, and
Yeah.
gradient implies differentiation. So it means that on a displacement time graph, if you if you differentiate a displacement function, you get a velocity function on a displacement time graph. If you
Mm.
differentiate, we're talking about differentiation, and differentiation implies gradient or implies change, rate of change. So if I differentiate, the gradient of the line in a displacement time graph is velocity. If gradient implies differentiation, then it means that if I differentiate something in the displacement in the displacement region, and I'm trying to find the rate of change, or I'm trying to find the gradient. Therefore, if you differentiate something, you differentiate the displacement function, the resulting function is going to be a velocity function. Similarly,
Mm.
similarly, if this a velocity time graph, there's a velocity time graph. What is this line?
Constant acceleration.
Constant acceleration. So, in other words, the gradient of the line. So the gradient over there is acceleration, right? The gradient of the line is acceleration. So if differentiation implies the what's the name? It means gradient, and this we are in the velocity region. This should tell you that when you differentiate a velocity function, you are going to get differential. So normally, what I use to memorize this relationship is this phrase diva. I don't use S for displacement. In this case, I use D for displacement. What this means is that if you differentiate a displacement function, you get a velocity function. If you differentiate a velocity function, you get acceleration.
Mm.
So you can note this one down. So there's my diva. I'll be using it in most cases. In most cases. So almost all the questions I'll be solving, I'll try to bring up this thing. So diva. If you differentiate a displacement function, you get a velocity function. If you differentiate a velocity function, you get acceleration. Is that okay?
Yes, please.
Okay, so the reverse is true for integration. You see, integration is just the reverse of differentiation.
Yeah.
Like the question you solved earlier, you differentiated a function and you integrated that function again. And if you check the solution, it's almost like the first function. The only thing that changed was a constant. You're having a constant c, but the other one there was a number. So integration is basically the reverse of differentiation. So if you differentiate displacement function to get a velocity function, it means that if you integrate a velocity function, you are going to get a displacement function. Are you getting me?
Yes, please.
Similarly, if you create acceleration function, you are going to get velocity function. So I'm going to use this a lot in my workings. And
Okay.
also, this one has got something to do with area. Integration has got something to do with area. Like if I take a velocity, there's a velocity time graph. Let's say there's a velocity time graph. How will I find the distance covered, the total distance covered?
Total distance covered.
Yes, there's
Uh,
a graph. In this graph, how will I find the total distance covered?
area under the
Area under the curve.
lines.
And area
Yeah.
represents integration. So if the area under the curve of a velocity function is giving me the distance or displacement, then it means that if you integrate the velocity function, you are going to get displacement function.
Okay.
So that is just the basis of everything. And this is what defines almost everything when it comes to this part of the kinematics. So I like it a lot because it's not so difficult. So please keep in mind we've got diva. That is, if you differentiate a displacement function. I know displacement is s, but
Yeah.
well, it doesn't really sound well.
Yeah.
I like to use diva instead. Okay. So diva differentiate the displacement function, you get velocity function. Differentiate the velocity function, you get acceleration function. Then the reverse is true. Integrate an acceleration function, you get a velocity function. Integrate a velocity function, you get a displacement function. Now, let's take a very first example. Um, the velocity of a particle at time t is given by v is equal to 2t squared minus 4t plus 3. Find the time at which the acceleration is 0. So we are given a velocity time graph. Sorry, not time graph. I mean velocity function. V of t is equal to 2t squared 4t plus 3. We are told to find the time at which the acceleration is 0. How can I get acceleration from velocity?
You differentiate the velocity.
So
Yeah.
acceleration is equal to dv dt. So change in velocity with respect to time. So this becomes differentiating this will be 4t minus 4.
Yeah.
Now we're told that we have to find a time when the acceleration is 0. So when the acceleration is 0, I can say that 4t minus 4 is equal to 0. Then we find the value of t. Is that okay?
Yes, please.
Okay, so do just that for me.
So t is equal to 1.
Good, t is equal to 1. So it's not anything that is complicated. Well, let's see how things are going to go. Here's a very first example. Let's see if you can try this example. The velocity of a particle at time t is given by v is equal to 5 plus 4t minus 3t squared. Find the velocity when the acceleration is 0. Okay, so that is very similar to what we did previously. Again, diva, you can write this anytime we start solving. But trust me, if you get used to this, you don't need this diva. Like, so that's why. You don't really need to write
Mm.
so that when you're solving questions. If you get used to it, you know what you're doing. Okay, so this question, we are told to find velocity when the acceleration is 0. Because the question is saying something about acceleration, it means that we are likely to get acceleration function. Now, we are given a velocity function as v is equal to 5 plus 4t minus 3t squared. This is a velocity function.
Yeah.
How can I get acceleration function from this again?
You differentiate.
Okay, so acceleration is equal to the change in velocity with respect to time. The vdt is going to be equal to 0, 4 minus, I think, 6t. Now, when the acceleration is 0, what we're looking out for is when is the acceleration 0? At what time is the acceleration going to be 0? That is everything we're looking out for. At what time is the acceleration going to be 0? So when this is equal to 0, what will be t?
Um, 2/3.
2 over 3. So
Yeah.
2 over 3 seconds, the acceleration of the particle is 0, which means maybe it has got a maximum velocity or constant velocity at that point. So
Yeah.
this is the time at which the acceleration is 0. Because we are looking for the velocity, we go back to the velocity function and we replace the t with the 2 over 3. So at time 2 over 3, the particle has got zero acceleration. So I can say that v is now equal to 5 plus 4 of 2 over 3 minus 3 of 2 over 3 all squared. And v is equal to
19/3 meters per
9
second.
over 3 meters per second. Okay. It has started raining here. Yeah,
Oh.
19 over 3 meters per second. So that is very good. So as you can see, it's not difficult, right? Okay, so let's see how you go. We're going to tackle this question. The velocity of a particle at time t, sorry, the velocity v of a particle at time t between t equal to 0 and t equal to 3 is given by v is equal to t cubed minus 6t squared plus 9t. Find an expression for a and the maximum velocity of the particle. Can we solve it together now?
Is it okay? Yeah.
Okay. Now looking at this question, there are some key things you need to identify before you even start thinking about the solving process of the question. Now the question is talking about maximum velocity. This key word, maximum velocity. What can you deduce out of maximum velocity?
Um, the highest speed the particle like reached during the whole thing.
Okay, so what has it got to do to either the velocity, acceleration, or displacement?
Um, maybe
For
when
maximum velocity,
velocity is
yeah.
constant
When velocity is constant, what do you say about acceleration?
is zero.
Yeah, there is no acceleration. So acceleration is zero. So when the particle has got a maximum velocity, then it implies that the acceleration is zero. Are you getting me? I think you
Okay.
did the explanation previously, so I don't know why you missed this one this time. Okay, so from this statement, I can note that acceleration is equal to zero. Now we're given a velocity function, t is equal to t cubed t squared plus 9t. Now guessing acceleration function, you know what to do. Acceleration is going to be equal to change in velocity with respect to time. There is going to be 3t squared if my equation is correct minus 12t plus 9. So at maximum velocity, acceleration is zero. So this statement will be equal to zero. Now you can solve for t in this quadratic equation. So do that for me. I think I can even divide through by 3. So this is t squared minus 4t plus 3. This is equal to 0. This should be very easy to solve. Two numbers when multiplied, you get positive 3. When summed up, you get negative 4. And the numbers will be negative 1 and negative 3. Therefore, t will be equal to 1 and t will be equal to 3. Now we are not done. So the particle got a maximum velocity at time t equal to 1 and also a maximum velocity at time t is equal to 3. So we go to the velocity function, which is t cubed minus 6t squared plus 9t. We do the substitution. V is going to be equal to 1 cubed minus 6 of 1 squared plus 9 of 1. Is that okay?
Mm.
Okay, so do the calculation for me. This is very simple. It should be 1 minus 6 plus 9, and everything is correct. 4 meters per
16.
second.
Oh, wait. Hey, minus 6.
Uh, Barry, are you tired?
No, no.
Okay, okay. So do the other substitution again. So when t is equal to 3, J is going to be equal to 3 cubed minus 6 of 3 squared plus 9 of 3. And J will be equal to
0. Say, it will be 0.
come again,
0.
0.
Yeah.
Okay, 0 meters per second. So
Yeah.
of the two, which one is faster?
Um, the first one, 4 meters per second.
So the velocity at maximum, the maximum velocity of the particle is 4 meters per second.
Yeah.
The maximum velocity of the particle is 4 meters per second. It's really raining heavily over here.
Mm.
Okay, when you're done, try this one.
Okay.
A car accelerates to overtake a truck on the highway. After passing the truck, the car slows down as it approaches a slow-moving traffic. Finally, it comes to a halt. The velocity v meters per second of the car after time t seconds is given by v is equal to 8 plus 0.36 t squared minus 0.02 t cubed. How fast? Find how fast the car is moving when it reaches the maximum velocity. So maximum velocity, what can you say about that?
Acceleration is 0.
Acceleration is 0. Are you through with that?
Yes. Almost.
I'll share my slides with you.
Okay.
Okay.
Okay. So I got V to be 25.28.
Come again.
25.28
25.28. Let's see how that will
meters per
go.
second.
Meters per second. Okay. So again, we're given a velocity function. Velocity function to be 8 plus 0.36 t squared minus 0.02 t cubed. And we have to find the maximum velocity. But at max velocity, we say that acceleration is equal to 0.
Mm.
And the acceleration function over there is going to be the change in velocity with respect to time. So this will be 0.36 times 2 should give you 0.72 if my math is correct. Is that
Yeah.
correct?
Yes.
Minus 0.06 t squared. This should be equal to 0. So you're going to get two different times. T is equal to 0. And what is the other time?
Um. I'm
It
coming
should
up.
be, yeah, 0.72 divided by 0.06.
I can't see 12. 12. Sorry.
12. Okay, so this is the time at which the particle reaches its maximum speed. So you can do the necessary substitution, you get the maximum
Yeah.
um, that
What
over
I
there.
was
So
saying is the people
B is equal to,
people's sales station where I am. Are you in class?
Yeah.
I think,
Online?
8
Yeah.
plus
What I'm trying to tell you is
0.36
whose warehouse
12 squared minus 0.02 12 cubed. So
Yeah.
do the
That's
manipulation. Yeah,
25.28
25.28 meters per
meters per
second.
second. Yeah.
Okay. So that's it's not so difficult. So the rest you just need to solve more questions. There are more examples, but my internet is kind of messing up now because of the rain. So
Oh.
go to the book I gave you. There are more questions over there.
Okay.
Solve that one. Then this is mainly based on the differentiation aspect. The integration aspect follows up later. So just solve more questions, then we'll meet later. I would like to end over here. The network is going to it's messing
Okay.
up because of the
Okay.
rain.
Okay.
Okay, so take care of yourself, and
Mhm.
it was good. So just solve more questions. If anything, just message me. I will respond as fast as possible.
Okay.
Okay, take care.
You too. Bye.